Hello everyone, welcome to my channel. This is Karuna teaching the course Computer Architecture and Organization. Fourth unit contains the following topics, out of which in this video we are concentrating on synchronous bus. Introduction. The processor, main memory, I/O devices can be interconnected by means of a common bus whose primary function is to provide a communication path for data transfer. The bus protocols used for transferring data. A bus protocol is the set of rules that govern the behavior of various devices connected to the bus. Basically, the bus lines are grouped into three types: data bus, address bus, and control bus. The control signals specify whether a read or a write operation is to be performed. Data bus. Data can be transferred in several sizes such as byte, word, or long word. The bus control signals also carry timing information. They specify the times at which the processor and the I/O devices may place data on the bus or receive data from the bus. There are several schemes for the timing of data transfers over a bus. They can be broadly classified as synchronous bus, asynchronous bus. Generally, processor acts as master. The device addressed by the master is referred to as slave. Coming to the synchronous bus, let us see how the data transfer takes place between processor and input device, because here we are considering read operation. That's what the device is, input device on synchronous bus. In a synchronous bus, all devices derive timing information from a common clock line. A bus cycle, here this is bus cycle. Okay, so bus cycle constitutes equally spaced pulses on this clock line. Define equal time interval during which one data transfer can takes place. Here one data transfer takes place during this bus clock cycle. Okay, the address and data lines, here these are the address and command lines, and these are the data lines, nothing but data bus. Okay, the address and data lines shown in this figure at high and low at the same time. Okay, the indication of these lines are high and low depending on the particular address or data pattern being transmitted. The crossing points, here crossing point at T0, okay, and T2 crossing points appeared. The crossing points indicating that the times at which these patterns change. Okay, let us consider the sequence of events during read operation. Okay, here the device which initiates data transfers known as master or initiator, and the device addressed by the master known as slave or target. Okay, remember these 2 points. Let us consider sequence of events during read operation. Okay, so this is bus clock. Okay, so at T0, the master means processor places the device address on the address lines. So this is the combination of address and control signals. Here master places the device address on the address lines and sends an appropriate command on the control lines. In this case, the command is input operation, that means read operation. The command signal specifies the length of the operand to be read. If possible, speed also can be determined. During T1 and T0. Okay, so here this pulse width must be longer than the maximum propagation delay between two devices connected to the bus. Also, it is longer enough to allow all the devices to decode the address and control signals. Okay, so in this duration, decoding of address and control signals are performed. Okay, so that the addressed device, that means slave, can respond at T1. Slave will not place any data on the bus before T1. Okay, so there is no data on the data bus before T1. Okay, at T1, the addressed slave places the requested input data on the data lines. Okay, so at T2, this is end of clock cycle. Okay, this is end of clock cycle. At this time, master stores the data on the data lines into its input buffer. That means here master collects the data from the data bus into its input buffer. Okay, here strobe nothing but capture the values of the data at a given instant and store them into a buffer. Okay, so T2 to T1, this period must be greater than the maximum propagation time on the bus plus setup time of the input buffer register of the master. Similar procedure is followed for an output operation. In case of output operation, master places the output data on the data lines when it transmits the address and command information. At T2, addressed device stores the data lines and loads the data into its data buffer. That means output device collects the data from the data bus. Okay, so this is a theoretical diagram. Let us see how the signals are going during the bus clock cycles practically. This is the detailed timing diagram of an input transfer operation. Okay, so bus clock cycle, and this is the address and command bus, and this is data bus. These are seen by master, means processor, and coming to this address and command signals, data bus, are seen by slave device. Nothing but here we are performing read operation. That's what the slave device is, input device. Okay, let us see how the operation takes place practically with the help of synchronous bus. Okay, here signals do not appear on the bus as soon as they are placed on the bus due to the propagation delay in the interface circuits. Actually, the placement of address and command signals on address and command or control bus at T0, but the signals will be appear on TAM due to delay in the driver circuits. See, address and command signals appear on the bus at TAM. Okay, later the signals reach the slave at TAS. Because of decoding process, data signals appear at TDS instead of T1. They travel toward the master and arrive at TDM. At T2, the master loads the data into its input buffer. Hence, the time period T2 to TDM is the setup time for the master's input buffer. The data must continue to be valid after T2 for a period equal to the hold time of that buffer. Okay, so the limitation of one clock cycle T2 to longest delay. Okay, so here there is a delay. Okay, so that's what here speed of the operation is slow. Also, in this case, processor means master don't know whether slave has actually responded or not. To overcome these limitations, most buses use control signals that represent a response from the device. Let us see how the control signals are used. This is the clock signal having 4 cycles, and this is address bus, command bus. Okay, here address bus, command bus drawn separately. Okay, this is data bus. Here one more signal is added, slave ready. This we can say one more control signal. We can say handshake signal. Okay, so most buses have control signals to represent a response from the slave. So control signals serve two purposes. First one is it informs the master that the slave has recognized the address and is ready to participate in a data transfer operation. Next, enable to adjust the duration of the data transfer operation. Okay, so here during clock cycle 1, the master sends address and command information on the bus requesting a read operation. Read signal is not displayed in this diagram. The slave receives this information and decodes it on the following active edge of the clock, that is at the beginning of the clock cycle 2. Okay, it makes a decision to respond and begins to access the requested data. The data placed on the bus in clock cycle 3. At the same time, the slave alerts a control signal called slave ready. This is slave ready. The master is waiting for this signal, stores the data into its input buffer at the end of clock cycle 3. At this end of this third cycle, master stores the data into the input buffer. Means master collects the data from the data bus. Okay, here at this time, slave places the data on data bus and asserts slave ready signal. Okay, now the bus transfer operation is complete. Master may send a new address to start a new transfer in clock cycle 4. The slave ready signal is acknowledged from the slave to the master. This is known as acknowledgement signal. Okay, confirming that valid data have been sent. The slave responds in cycle 3. Another device may respond sooner or later. If the addressed device does not respond at all, the master waits for some predefined maximum number of clock cycles, then aborts the operation. That results there may be incorrect address or a device malfunction. Okay, so likewise data transfer takes place between processor and input device in case of read operation with the help of synchronous bus. Okay, so here all operations must be synchronized with the clock cycles. That's what this is known as synchronous bus data transfer, because synchronous bus is used to transfer the data between processor and input device with the help of timing diagrams. Thank you. We will meet in next video.